Hello, everybody. Today, this is Bernard here for the webinar series 2 here. Yeah, today we are going to have a CATIA legal harness session 2, where we are going to cover today on library creation and harness stuff. Please let us know, is it audible? Before we start, please let us know if it is audible. Right. So at any point of time, if you have any audio issues or connectivity issues, please do let me know so that I can help you out in solving the issues. Right. Okay. All right. Okay. Once again, welcome you all. Today, let us go for the plan. As per the plan, here today we are going to learn some issues. Please hold on. Yes. Today's sessions, we are going to work with the electrical standard parts, library parts, the creation of library sessions, and how to create library. In the last session, we did about the entire the process of electrical and the methodology. Today, we'll be having a brief demo and the working principle of electrical harness. And to have a knowledge of wire harness, main routing, segregations, and the separation requirements, what is required for wire harness, to have some basic ideas about basic configurations or basic steps or basic rules which we need to take it up while doing harness stuff. And then we'll cover on the electrical category for electrical part design, electrical assembly design, and electrical harness. So I'll be just doing this PPT and demo parallelly so that you can correlate your learnings or your observations on and off basis. Okay, to go with that. So what we have today is that a creation of a standard components. What is this creation of standard components? When we talk about creation of standard components, it is about the mounting equipment. We talk about something called equipments, we talk about shell, we talk about connectors, contact, and electrical components, and back shells, and the support components. So, as we discussed in the last webinar session, that any components which we need to convert into a mechanical component, it needs to be converted into either of these electrical components. So, until unless it is not converted into either of these electrical components, you cannot convert those, you cannot use those components for electrical harnesses. So the first foremost requirement is all your standard components needs to be converted into a standard components. So this is how we define electrical components terminology. Once you define that the component, say for example, you have a panel board. The panel board is of your car is a mounting equipment. Onto that panel board, you may have a number of switches, connectors, all these things. So now your panel board is your electrical device. But hardly speaking, it's a plastic components which are positioned, or composites which are positioned for manufacturing. So the mechanical components needs to be converted into electrical components. That's what we define here. So once you define here, what is the connections between each? How this mounting equipment is placed, how the switches are positioned, and how your electrical connectivity between each terminologies like bundle connection point, cavity connection point, back shell points, all these are very important parameters. So the first step is converting your mechanical components into electrical components and saving in a catalog and use it whenever you want to use it. Okay, reuse it. Okay. So to say it simple, what is this connecting principle talk about? Here we talk about okay. So here we talk about an equipment. can see here an equipment. This is your equipment. This is your shell. Okay. Yeah. This is the shell, and this is your other connectors. So how this connection happens is what we need to see here. Now, when you work with this electrical part design and electrical assembly design, these are the three things. So this is a mechanical component. First, you need to define that this component is an equipment. You see here, this is an equipment. That means the gray component is an equipment which needs to be converted into an equipment having a cavity. How many cavities? 1, 2, and 3 cavities. So it is having 3 cavities over there. So you need to do that. Similarly, what it can receive at the other end is it can receive a shell. It can receive a shell. That's what it is mentioned here. It is having a equipment and it is having a shell which can receive cavity. So what we need to define here is we need to define here that the component is the shell having cavity connection part. Now we first stage converting into equipment shell, then defining this terminology so that it gets connected. So how it is getting connected? It is connected in electrical assembly design. So what does this electrical assembly design does? It connects all the electrical equipments and devices. Still we are not talking about this harness. Harness comes here at this point. So here until then it is all about your standard. You can able to understand this. If you have any queries, you can ask. So this is the entire principle of creating your standard components. So coming to this side, if you have a component something like this, say for example, here you have a mounting equipment. So it is having a cavity. What it can receive, it can release a cavity connection point, and what are all the devices it can get, you can able to see. So this is how the entire workflow of component is. So if it is a shell, you can see here if it is a shell, it can have cavity and it can receive other components, what single insert connector, star, terminal, contact, all these things, having cavity connection point. All right. So this is how the entire working principle of electrical part design works. And this is how I told you, once your electrical components are connected, I need to use a connective connection between these two. When I want to connect it, I will use electrical assembly design. So that this connection is connected. This is the connection. Okay, it's connected. Do you hear me, please? Okay. So I'll start with a demo. Finally, you can ask me what are the doubts you have. It. So I'll open a file, uh, new catalog. First, I'll teach you the create a catalog. I'm going to put the catalog into the system. I understand that the speed needs to be reduced, so that's the reason. Okay, thank you. Here you have the conference. Before starting the conference, what we need to do is I'll create a catalog of electrical components. Say, for example, I have my data here. I'll create my desktop. I'll create one standard folder today. All right. This is my component. I'll just copy this first. and I'm going to open a component. I'm going to create a catalog now. So what is the catalog? I'm going to name here as, you can create n number of components. Let's say, for example, here, I'm going to add a family. What is a family? I'm going to add here family as electrical component. Say, for example, uh, the electrical. So I'm creating standards of electrical. So once it is done, you can able to see here the connector electrical system, and I can create one more connector. For example, create one more electrical. Say, for example, equipment. Okay, you have things. I can create one more. Say, for example, electrical model, or you can make it as, for example, shell. Okay, so you create all these things and save it. So I'm going to create file, save this catalog on my desktop. Okay. As electrical catalog. So I created this component and save this catalog. So now what I do, I'm just going to put all the components and save those components into the database of these catalogs. Okay. So if you feel slow, you can just tell me speed, because we are accessing some data. So I'm going to take here one of the components called connector. For example, I'm going to take connector. So I'm going to drag here, or I'm going to take one equipment. I'll take one equipment. Now, before accessing the module, I'll just tell you what is the electrical module you need to do. First thing you need to understand, this is your electrical module, and in this we are currently working on electrical part design. This electrical part design, where you can see is go here, equipment, electrical part design. This electrical part design is the workbench which we are going to work on, right? All right. So in electrical equipment, as I told you, we have two things. One is uh, electrical devices and electrical connections. So what I'm going to do here in this case is that I want to create a standard component. I mean to say I want to create a standard component and defining this as an equipment. As you know, this is an equipment. I go here and click on equipment. So this is my equipment. I can name it as something called QA. If okay, you go there. CATIA V5 electrical harness has one capability of storing those components into a catalog. Already we have created one of the catalogs. So what I'll do, go here, I'm going to save this first. First I'll save this. I'm going to put this into a catalog. You can see here, store device, put this device, get into the equipment where we have created it. So you can go here. Just now we created in the desktop for today. We have seen that. So go here, and I have created this one. So in that we have created three families. So you can select your equipment. Just put it there. So this is one where we have defined this. But before doing that, yes, we have just defined this as an equipment. But until unless we are not defining this as a connection point, it is not behaving as a. So what I'll do with this, I'll convert this into electrical components. So what is this? This is having what this is what cavity. This is cavity terminations, all these things. So here I'm going to define that this is a cavity. See, I'm going to define here that this is a cavity. So my representation is this, which tells this is my face, and this is my contact. The other component shell needs to come and sit here, and my coincidence of constraint is this, and my orientation is this. So orientation means it should not rotate with reference to that axis. So once you click this OK, you can see that in the specification tree, this particular area where you can able to see, I think, yeah, you can see this now. You can see here electrical component is being created. At the same time, you have all your components. You have all your publications here. You can see the publications. This publications comes default when you convert all your mechanical components into electrical components. All right. So you have logical dimensions, you have cavity dimensions, all this. So this is the algorithm. Like any time, whenever you convert mechanical component into electrical components, it gets published. So until now, we have defined there is having two cavities. So I'll define one more cavity. See here what happens here in this particular location. Click here. This is my representation, and this is my contact. The other component going to come and say this is a line of constant. This is a orientation. Here, okay. You can see here your publication comes here at the bottom, right? You can see here. And similarly, I'm going to create one more cavity here. Connect here. This is my coincidence, and this is my orientation. Yep. And you need to save this first. Save this, sorry, just saving this. I'm going to put this into here, same it. Similarly, I'll open the other one called shell. So you can see here, once I have created this, you come here, click here, you can see the preview, the catalog which has been covered very well. So similarly, if you see here, there is no connector here, right? So because I have not put any connector here, so I need to connect, I need to give a component to convert into a connector. So what I'll do, I'll take this connector, device connector, shell, I'll take this shell, for example. If it is not audible, please let me know. I'll increase my voice, or I'm going a bit slow because the reason of connectivity issues or bandwidth connections, because we are opening with CATIA. That's the reason. So you can just have a look. If it is slow, please. So I'm just opening this component where you have a shell. You can see this is my shell. So I need to convert this as a define a shell. So I'm going to define this as a shell. Yes. So this component is a shell, where the other component is cavity connection point, and here I'm going to convert this into a cavity connection point. So here you can see it's a bundle connection. Here you can see cavity connection point. Click here, take this point and reference it. This is my face, this is my contact, line of accident is this, line of orientation is this. At the same time, this component on the other side is having a cavity. So I need to define here as cavity. See, this is my cavity, representation, contact, line of coincidence, line of orientation. Give OK, and just save this. I'm just saving desktop and direct. Right? And I'm going to store this where, say for example, shell. Now if you open that shell, if you open this shell, you can see that the component will be here. Right? So you can use this. And there is standard creation of library which you may not be required at the moment, because most of the time when you execute the project, the standard components you will be getting from your customer, so no need to put a lot of effort into it. Sometimes what happens, you may have some IGS or step data to be converted, and you can just convert those IGS or step data or neutral format of any data into a catalog. This is how we need to do it. So you can create a catalog, put all the components into the catalog as per this store device. So what we learned from here is that Yeah, I'm just repeating here. In this is, you need to define electrical components, you need to define what is the connectivity, and storing all your components into that. Similarly, we have other things like back shell, you have protection tape. Protection tape is nothing but a corrugated tube or a texture where you need to use it as a tape or a corrugated tube so that it is used as a protection tape, protection part. And that also you can store it. Say for example, I can create some material properties, and if the protection tape is made of rubber, so that you can put it there in the storage. Okay. We have one more called adaptive support. This is called support, where you need to convert any of the component into support. See, I'll take an example here. I'm taking a component from the same part library. So this is my support. I'm just dragging this support and taking it. So what I'm doing here is, this is my component and I want to convert this into a support. So what I do here, define a support. I'm going to define this support, and this is my point where my bundle is going to come inside, and this is the plane where my bundle entry phase. That means my bundle enters through here to this place and to this phase as a reference. So I'm going to select this phase as the plane. Then it enters from which plane? It enters out of this plane. So that's the reason you need to see it enters out. That is exits. It exits from this plane, and if required, your bundle can sit on this retainer. Okay. So now you can say store this. Before that, I need to save this. I'm just saving this, and I'm going to store it. I'm going to store that. Where? Say for example, connector. And I'm going to. So now get into catalog, and you can see your connector. You can see this. So this is a very basic and fundamental approach of converting your components into a standard component. These are library creations. So now let us take an example how we do that for a case example. All right. Here we have a component, so where the entire aircraft you can able to see here, and in this entire aircraft, I'm going to take the nose part where you have the electrical system. Okay, you can see here. Okay, so these are your electrical systems. So let us see how you are going to convert your standard components into electrical components. So one of the example is here all your electrical components are placed inside this, taking into account into a spacing. Okay, so spacing is a factor. So what we are going to do here is, I'm going to convert all the standard. You can see here is a back shell, this is a back shell, this is a support, this is a support, it's a harness support. So the same example, if you see this side, I'll rotate this component this side and hide this. Okay. And take this, hide this, and hide this. If you see here, right, this is your standard components, right? And how this is a electrical equipment. This is an equipment which I want to assemble this. You can see this, right? Here. So I'll take an example here. Same where we are doing this. So I'll just go here. Okay, and see that. Look at the data. Go to the desktop. Get into the data here. I'm going to take this. Same, what you are seeing here. All right, the same component. Now, I defined already that these components are electrical components. You can see here, all these components are electrified. You can see this spark signal, which tells that these components are electrified with the terminals. So now what I'm going to do here is, I'm going to assemble it. So how I'm going to do it is, here we go with equipment, electrical harness assembly design. Sorry, electrical assembly design. In electrical assembly design, you are assembling all your components inside assembly design. That means the same icons or the same commands will be there here. Only thing is you need to connect that. So what I'm going to do it is, I'm going to connect this component with this connector. Okay, you can see that it goes and sits automatically. This is nothing but your assembly constraints, all your assembly constraints, which we have defined as an electrical property. Now I want to make this component go and sit. So what I'll do, I'll go here, connect this one with, so it goes and sets it automatically. So this is how your standard components are created, and your electrical assembly design, you have your electrical components positioned here. Okay. So what we learn from here, I will put a question, which is, what is the role of electrical assembly design? Means, what is the answer? Anybody? Can you tell me what is meant by? Please raise up your hand. What is electrical assembly design capability? Anybody? Okay. Okay. So I'll just tell you. In electrical assembly design, what I see here, main thing is this one. We are getting connected to electrical devices. That's the one important thing of electrical assembly design. Now, what you saw until now is creating of your standard components into electrical components and storing in a catalog, and using those components for catalogs, components for assembly in electrical assembly design. This we can do by automatic process also, which we'll do it in the next session, called advanced level, where we'll be using managed representations. So where we'll be using physical managed representations. Okay. So you have managed representations where you'll be using that. So one important thing what you learned is here is store device. You can store that. So now I'll go back to PPT and tell about what is electrical harness assembly. So until now we know what is electrical assembly design. Now we are going to electrical uh, harness assembly. Okay. In electrical harness assembly and installations, the first and foremost requirement for doing what is the use of this electrical harness assembly is from to connectivity. That means from where the electrical harness starts and where it ends is the from to connectivity. And why we do it? We are doing that in a digital markup environment, in space environment. Creating a geometrical bundle is the foremost requirement. So the first point you need to understand is, without a geometrical bundle, you cannot able to create any of your harness. So the first foremost requirement in electrical CATIA we talk about is GPF. So this is what we talk about. See here, this is what is GPF, geometrical bundle segment. So until unless this geometrical bundle is not there, you cannot create it. Number two, when you create any of the bundles, you can have in two formats. One is as a multi-branch and one more as a single bundle segment. So what is the major difference between these two? Multi-branch is a branchable. You can see as a branchable. Whereas bundle segment is a single cat part. It is only one bundle. So multi-branch means you can have n number of branchable components. Okay. So what is the basic principle or basic understanding of harness assembly? I'll tell you why it is required and how it is very important. So any of, for example, I've taken an aircraft as a system of flying system. Very important is how your harness routing is done. why harness separations, why bundle is done. Any routing starts from main routing. So from main routing, it segregates to all the other routing systems. So you need to be very cautious. You start the routing from the main. And it depends upon how many bundles and how many wires inside the bundles. When you go for any of harness routing, the first and foremost requirement is you need to have a general installation principle. Connector installations, clamping where the distance, support failures, distortions, installation hardware, mechanical protections like tape or breaker tube, and you need to see the clearance between the subsystem. Very important is this that the fluid lines or the structural edges or the moving parts of the structures. Say for example, if you have a fluid flow, fluid or fuel flow, what should be the distance between the fluid flow and electrical cable? If you have a structural edges, sharp edges, that edges should not cut your wires. So that is also very important. So moving parts, how you automize your electrical harness cable. So how you can sustain the EMI effects. So some of the very important. Why harness clearance is very important. Sacking is required, drilling in the breakouts, and sometimes very important is what should be the bend radius, what should be the slack, what should be the drip loop, what should be the grounding systems, and what should be the service life maintainability. That means when maintenance happens, that time you should be able to see that you can able to easily plug your cable and change with a new one. So modular design of electrical harness is required. If modularity is not there, it will be very difficult for you to design the process. So these are some of the important factors we need to take care of while generating installation process. Now, what is this? Is that when you work with the you can see this. Very important is you may have a n number of cables coming in, a tight cable coming in. So you need to be very careful in placing your batch loads required to interface. There is no interface happening between the cables. So very important is position your components, position your batch connectors, and grounding equipment in the systematic format. Okay. Typical. What is the typical process? Say, for example, I'm just giving you preferred 1 inch from the surface, 1 inch minimum. This should be the standard. Each and every OEM has its own standard. You can fix that standards. That from the cable, this should be the position. Okay. And general installation principles. See, for example, you have here where your connectors are here. You can see here when the aircraft is flying vertical or horizontal, how your cable should be there. It is mandatory that when aircraft is flowing in this direction, for example, horizontal direction, your keys should be at the top. If the keys are not at the top, what happens? There is a chance of plug off, and it should be opposite to the direction of flow. So that and any circumstances it doesn't come to. Similarly, you can see when the aircraft is when the connector is in a vertical direction, what should be the position of lock key of your electrical key connectors. So these are some of the very important things. Another example here. What should be the correction? Clamp position. So each, P clamps are there, C clamps are there, P clamps are there. Each clamp has its own preferences based on your practical applications. If it is a static load happening on the components, the structure, so you can see here the structure, and in that structure, how this is the correct. So you cannot position your connector in this direction. And sometimes what happens, this is not a preferred one because there is a huge gap. And see here, there is a deformation on mounting force. There is a small deformation. There is a chance for catastrophe. And here, if you see here, the angle 90 degrees needs to be maintained in either of this vertical direction. So these are some of the important factors for resonance and chamfering effects of your components. Some examples, like acceptable when space constraint comes here. So see, this is acceptable when space constraint. Not at all recommended because more number of loads will be acting on this, a dynamic load or static load. This is a preferred. If you see here, this is not recommended because if it under a cable will be here and a cable will be here, it can have a bend, so there is a chance of flutter and it can hurt the other components. So these are some of the important factors which you need to consider while routing or positioning your clamp for cable holding. Say for example, P-clips. This is a P-clip where you can position your P-clips like 90°, incorrect or correct, like this. So it should not be like here, incorrect. This will be a great challenge. So always you keep it at 90°. So preferred angle of cable clamps, like for example, acceptable. These are not acceptable. This is not at all acceptable. You cannot keep your cable clamp like this. Here you can keep the acceptable, not recommended. Say for example, there are different principles of holding your cables, especially for the clamps. When it is a static load for all bundles, for an example only, this is just an example. For all diameter loads, this should be the position of your clamps. And if it is for some OEM, if it is a static load, you can define if the bundle diameter is less than 25, your clamp position should be like this. So it will be very important. So these are some of the best principle or standard principles for clamping components. Now, improper installation. So see, you can see here a practical case where the cables are not positioned, clamped properly. So properly, it should be clamped on the both longitudinal as well as rotational movement of the harness. The same case here, the rubber wedges where there is no pitching. If there is no pitching, there is a chance of the components coming out of the thing. So this is very important. Rubber cushion is mentioned where it can hold this. This rubber cushion also sometimes acts as a protection tape. So this is the correct method of tightening and pitching of your wires. You can see here. So if your cables are not tightened, the slot will be there. Clamp slot will be an issue. So you can see that this will cause a tremendous plug off and a tremendous distraction from the harness to go off. Some more inputs like other components are there. So there is adjacent wire supports. How the distance maximum it can the cable uh, can go a distance of 1 to 5 inches. Okay. So this is some of the things. See here, very important. You have a connector support here. Here also you have a connector support, and here also you have connector support. So incorrect. Just extend your connector support to straighten, then you just join position it. So here what happens? Here there will be hysteresis flaw, huge amount of heat will be generated. There is a chance of the wire damage. Some of the important things: how T breakouts happen, how Y breakouts. So they'll give you a suggestion that this is a no clamping zone. That means at this particular point, wherever there is a Y break or T break, you cannot position any of your clamps. So that is the standards given by each and every organization. Okay. General installation, especially whenever you work on as bundle protections, shape and size, environmental conditions, available mountings, and material is very important in terms of a mounting space and installation maintainability, especially on maintainability. Right? Some of the effects of why the protection is used is AMI effect, ANC effects, mechanical movements, fluids, and vibrations. So these are some of the important parameters which you need to consider before you harness it. Some of the general instructions. See, you can see the first one. The cable needs to be against the sharp edges, reposition it. So you need to keep a rubber push here so that the cables are smooth enough to pass to the next components. Right? So similarly, if you have any flammable liquids or gases, you need to see that there should be some distance, some protection sleeve or carbureted tubes for harness deflections. So under any harness deflections, you need to see that your flammable liquid gas tubes are not in touch with your electrical cables. So sometimes what happens, these are the chamfing. So if you're not properly keeping your harness, what happens, your fuel tube and your electrical harness will just jump into the hydraulic sides. So it may cause a catastrophe to any of the. These are some of the very important uh, process of harness installations, where you need to be very careful in providing a subsystems of moving components. Under any vibrations, what happens, right? So some of the very important correct things that you can just have a look at. This is the solutions. Don't keep it either junctions and keep for more number of supports and connectors. So there is should be a uncontrolled force that happens on the harness because of uh, positioning all your cables in the right positions. So ensure that it is positioned in a 2D plane and 2D branch, and ensure that it is not interfacing with other components at any point of time. So this is a general installation. So drip blocks, you just see that some of the connectors where due to weight itself, it can behave as it can plug up. If the cable weight itself, it takes more, it can plug up. So it's very important that we need to ensure that it is fastened properly, right? Now let me take into an example in CATIA how exactly the harness is done. Okay, so all this what we talk about is electrical harness, all right? All the cables. So before that, I want to just show you how electrical harness assembly or electrical assembly models works. So if you see in equipment, you have electrical assembly design, which we know earlier, electrical part design. Here we talk about electrical harness assembly. So once you get into electrical harness assembly, sorry, okay, just close this. Right. So I'll just get into one of an example where I'll show you how electrical harness is done. Example, right? Exercise. Okay. So you can see here one of the structure where you want to route it. So the first thing what we need to do is I'm into electrical harness assembly workbench. When I'm into electrical harness assembly workbench, you have all these components. Okay. So in this, what I'm going to do it here is I want to define that this component is an electrical model. I'm going to define that this is an electrical harness component. So what I'm going to do it is, first thing is I want to convert that into, I'll just show for a new one. I'm going to insert a new product into this one, and I'm going to activate this one, and I'm going to route it. See what is the error it is showing? Request to activate another. That means here, as I told you, initial stage, you need to have one geometrical button. So what I'll do, this is my geometrical button. I am going to define that this product is my geometrical. Once you do it, then you can start routing whatever you want. Okay. So I'll just activate this. I'll show you how to bring your components, standard components into this. So I'll just jump on. So I want to bring support. So when I want to bring in support like clamps, all the things, clamp is a device. It is not a harness. So I will just get into uh, harness model. So for example, I'll just get into the electrical assembly model, where we have one command called smart placement. Smart place. So I'm going to click here, and I'm going to bring this competency. Click on this, and I'm going to place it here like this. I can place here one, like this, right? And I'm going to place the others here, the support here, and I'm going to place it here. So I'm going to place the other one here. I'm going to use it here. So you have here all your standard components, and you have your placement standard components place here. That is your support. So this is how you place your component, electrical component in this smart placement. So now you have placed your components, that is your supports. Now what we need to do it is we need to route it. So what we need to do it is we are getting into an equipment electrical harness assembly. So placing your connectors, we are doing electrical assembly design. Routing is done using electrical harness assembly. You need to be very careful. The harness assembly is for routing, electrical assembly design is for placing device. Now I'll go to this electrical multi-branch where I can define my diameter. Say for example, I'm defining my diameter as 10. Okay, and this is your branch formed. This is your routing branch, multi-branch. So where I'm going to define what is my bend radius. Based on my bend radius, what should be the slack? So I can maintain what is the slack. And if you want to maintain the ansat, you can maintain the ansat. So I'm here maintaining the bend radius. So I'm going to route it. I'm going to route my harness to this. So it is asking keep people to selected out. Yes, I will keep it. Next is this. Yes, it is routed to that. Then I'm going to route it to this. Yes. These are the three uh, supports where the electrical harness are routed. Okay. Now if you just go, okay, fine, you see here the slack is 1, 2. So if I reduce the slack, you can see the length. That you can see it becomes straight. Okay. If I give 0, it becomes straight. See. So now what is that? It tells us for each slack value, there is a length. That means from here to here, from one support to the other support, what is the length total? If you see here, it is 480, 58.406 is your length of that. So if I change here the slack, say for example 1%. So what is happening there? You can see that. So I just click apply, and you can see the increase in length. 62.9. Again, 3 applied, you can see this is getting changed. Right? So this is how you start routing. There are 4 methods of routing. One, directly. One, this is one of the methods where you place your supports and start routing. Where you can control it by slack length, because you need to define length that distance from here to here, it should be like 470. So it takes default 470. You don't have control of slack, so it takes automatically slack. If you want to have a bit bend, you can give it with bend. Here, straight bend, yes, it's almost like a pipe. So now, most of the time we use slack, and slack is the thing which where we give in terms of percentage. So what is that slack? The length from this point, this support to this support is 100 mm. For example, from here to here is 100 mm. That means it takes 101 mm. That is 1% of your slack. So 1% is given as a tolerance for that. Right? This is the case. Now, the next scenario is that one is placing your like this. The other scenario, I'll just show you. I'll show you how to place your cables. Sometimes what happens, you tell, okay, I want to change the uh, this cable itself. I mean, I want to change the support. So what you can do, you just snap it and you keep it on this. Sorry. Just getting the geometry bundle. What I'm doing is I'm just changing it. So it gets automatically updated. The cable gets automatically updated. Okay. So this is one way where you start routing the electrical harness. Similarly, I'm showing the same example how the routing is done. For example, okay. See, we have your components now. So already I defined that this is the point where it's done here. So what we need to do here is get into this particular component where we have it here. Okay, just wait. It's taking some time. Okay. Okay. So here I'm going to make a routing. So I can just select here. So it's not here. So I will select one of the bundle. So what I'll do here is I'll activate this. I'll insert a new product. So you can see this is my new product. So I'll just convert this into Java. And start up. This is not active, so make it active. Once you make it active, it start out. So how to routing is done? You can take this bundle, say for example, take here as 20, and from here I'm taking root definition. Yes, take here, and here I want to make the cable to get through this. So I'm just selecting here. Alright. So cancel this because I've reduced the parameter to uh, and when you keep it here, it asks for that. I can place it on this. Now you can see here the slack is coming. I'm just selecting this also. I can take it here. So this is waiting for that. Let's go. Okay. Okay. So you can see that entire harness is being routed here. The real requirements. Okay. So now you want to break this, you can just double click on this. You need to have a bundle segment definitions where you can break this. So where I break, I just broke that particular bundle at this particular point. And I want to keep the diameter here less. So for example, here as color. And here the slack value is 2. That's the reason it's taking 2. So if you reduce it, you can see that. That is to 1. Harvest. Still, you want to reduce it, you can reduce it. So I want to make it here, say for example, 0.5. Okay. Here, you can give. Sometimes you feel I don't want slack between this. Sorry. Yeah. Sometimes you feel I don't want slack between this. So what you can do, you can get into that. I can have something called a local slack. Add a local slack. So here you have add local slack. Just click on this and click on this point. So it takes between these 2 points. So I can ignore apply. So of my geometry, yes, it's simple. Because my render is not in the part. Okay. So what we learned today is that how to use your electrical harness, geometrical bundle, and how to use multi-branchable, and how this multi-branchable and electrical harness are connected. So I'll take one more example, last two examples, so that we can able to understand and conclude your sessions today. I'll take one. Um, okay. Yeah. So CATIA EFA electrical harness has the capability to have a lightweight data also. So here what we are going to do it is, I'm going to, one way of routing is using the clamps. The other way of routing is that using the surfaces. Okay, where I'm going to use this surface as a reference. So what we need to do here is, so convert first into geometrical bundle, because here is no geometrical bundle. So you start to create a harness, will show you error that this doesn't have any geometrical bundle. So what we need to do, convert into a first geometrical bundle. So I'll convert this into geometrical. So then activate that where you want to route it. There is a best practice to do that also. Then click here, start routing it. So I'm just making, for example, column. What I'm doing, I'm just using control key. Just press your control key. Start routing wherever you want to do it. So you can use your control key and start routing. Okay, apply. So if you see, you're using just a control surface of the existing CGR format, CGR data, and start routing it. So still, if you want to incorporate, I'll just ignore the slabs. Leave the slabs here. Apply this. What happens? You have here. So this is one way of, sometimes you want to add one more component. So you can click here, add after that, you can create after that, add. I want to remove this. So you can remove this. Once you click on this mode, this is what we have. I mean, to use the electrical harness on this app management. Okay. So you have something called automatic. So these are the options where you can maintain your bundle from the center, bundle is from this surface to this surface. So you can maintain that. So, okay, right. So with this, we just have a session in terms of what you learned about electrical harness assembly, where in electrical harness assembly we just worked out about how to use geometrical bundle and how to use it, how to use local slam. There are other things, other commands which can be very helpful, but we cannot cover everything. So, what is electrical harness capability in terms? So, any questions you can ask me.